welcome for this new topic. We will speak now about minimum facility location problems. And to deal with this topic, we will present you 3 different cases. We will first present now the algorithm that we will use, and then we will apply it to different problems. First, you have to know that to minimize the cost, we will take into account the transportation cost. Every case, we will have 2 algorithms. First, in each example, we will compute the cost with an appropriate algorithm because each data are different, and so we will have to have different costs. And then we will use the same algorithm to solve the problem, to minimize the cost, and I will explain you now this program. This is our program, and in green you can see this is our explanations. So here we put an Excel pages because the thing is that we will have different values. So we will have different results at the beginning and different costs because we don't have the same example, as you can understand. The thing is that here the table will be different. And so now the thing is that we want to know the length of this table to apply the program for all our different examples. And that's why the first thing that we will do with our program. Yeah, you have to know that L, this will be always the column for our table because we choose to put all our total cost in the column L. It was easier. So the thing is that with this loop, we will compute the row number of the first empty row. What it will do, it will take length with equal to 1, so the row is 1, and it will always add 1 and 1 and 1 until that there is nothing in the cells. You see, value is different than nothing. So until that it will be different than nothing, it will continue. And so we will arrive here because it's always length plus 1. So here you see that there is something. So we will do length plus 1 and we'll arrive in row 5. And after, so to have the correct number of row, we will do length is equal to length minus 1. So we'll have 5 minus 1, 4. And we have, here you can see length minus 1. And at the end, we have the good number of row and the good table. And now what we will do is that with this table, we can calculate the minimum value, the minimum cost. So first, what we will do is that we will put in min one of our variables, that mean minimum, the cells T12 point value. T, it will be at the beginning 2, because you see that our first cost is 2. And we will, with this loop, compare the variable min with the other locations and change the variable each time the cost is lower. So, while T is inferior to length, so while T at the beginning 2 is inferior to length that we calculate before, if min, so at the beginning 123, is bigger than the value in the cells 1 plus T, that means here 323, then min will be equal to T's value. So for example, the first time, we see that 123 is lower than 323, so this will not happen. So we'll have directly T is equal to T plus 1. So after it will compare that with that, and we'll see that it will do the same. But if there is only, I don't know, if there is only 2 in the cell in these cells, we will have 123 with bigger than these cells. So the minimum will take a new value. It will be this value. So that I said it was 1. And at the end, we will row in. We will allow to take the value of the row of the minimum, of the new minimum. And so at the end of the loop, we have we know the minimum and we know the row of the minimum. And so we have just to give to save the name of the best location here. And after, we display the result with message box.
I'm going to talk about the minimization of the transportation costs. Unfortunately, I have only 3 minutes, so I will show you my Word document so after you can understand everything. But so the main things are we're going to build a factory to distribute some water in the Alps, so distribute the water to the whole France. So we will compute the cost from our location, our factory, to the different highways who are after going to all France. So these four locations are the four possible locations where we'll build our factory. So to compute, so first the cost, so we will compute them for 1 year, assuming we have 3 trucks leaving the factory every day, and that the trucks are driven 200 days a year. So, okay, here you have the distances, here altitude, here the number of days per year with 20 centimeters or plus snow falling, and here some data on the price of gas, the price of 1 kilometer, the price of the cost of the driver, everything. Okay, so this is all my code, but Foucault already talked about this, so I'm only going to talk about this part here, which is the part when I compute my costs. I took a picture that I put here, so it will be easier after for you to understand everything. And this cost here, you can see it's empty, and after here is where the cost will be. So what we do first is we sum the cost, okay? I will take the example of Mont Blanc. You sum the cost here. After the altitude is, since we're not in a flat place, we are driving in the mountains, the brakes will be used a lot, and then we'll have to change them more often. This is here why I'm computing the difference of altitude. Times 2 times 20 is because the trucks are going and coming back to the factory, so times 2. And times 20 is we assumed that 1 meter of using the brakes in the mountains is worth using the brakes for 20 meters on the classic highway. And so here P is to compute a ratio. This 80,000 is the fact that the brakes should be used after 80,000 kilometers being driven. So we'll see that for us, of course, it's less than this. And here N is the snow. So when we have 20 centimeters of more snow falling in one night, the trucks are not able to drive because the roads are blocked. So they have to wait for 2 hours for the snow to be moved and for the roads to be safe again. So this is what I'm doing here. So we have the number of days with that much snow. Here is because the trucks are driven only 200 days a year, no more. Here is the wage of the driver. We have to wait in the truck, of course. And here are the 2 hours in minutes. So finally, my costs here. So I put the sum time the price for 1 kilometer. So computing the wage plus the price of the gas. So times 400 because we compute the cost for 1 year. So 200 times a year going and coming back. Plus P, so for the altitude, and plus N for the snow. Okay, and here I will put this value, final cost, in this cell. And okay, after we put next I, so we'll do the same for Bourg-Saint-Maurice, Lancy, Bonneval-sur-Arc. And when I'm running my program, you can see the cost just appeared here. And Excel told me that latency is the best solution for me. Okay, thank you. Goodbye.
Talk about the case of transport cost minimization for bike taxi in Paris. François wants to launch his business in this flourishing market of bike taxi. So he's looking for an accommodation in Paris. He doesn't care about the location, but he wants to minimize transport cost, taking into account the price of the rent. So I've chosen 11 different flats in Paris, and to look what place is the best for him. So François only moved between all those 11 touristic places, and for his first ride of the day, he used an alternate reservation. So he doesn't know where he will start the day, and it's an equal probability between all of them. So the price of 1 hour of a ride is 45 euros. But François is an auto-entrepreneur. It's a special French legal statute, it means self-employed, and he has to pay this tax rate. So he earns for real 25.695 euros per hour. And I've assumed that his average speed is 11 km per hour, which is quite normal for an urban environment. So in Paris, there are plenty of streets. You never make a big detour. And François is biking, so the different speed limitations do not matter for him. So I assume that I can take the distance as a crow flies. So theoretical distance with this method are close to the real distances, and it's avoid me an inefficient work. This means finding all those data on Google Maps, and instead of that, I just find off Google Maps the GPS data of the 22 places, and I use this formula to convert in a distance. So now let's talk about the algorithm to solve this case. So here are all the variables we will need. So this loop is to compute the average distance of each apartment. So I'll just adding all the distance between here, between the apartment and the 11th place, and I'm dividing it by 11, and I will have the result here. So next, with this loop, I will have I compute the cost per week. So here are the price of the rent. I multiplied by it by 12 the number of months in a year, and I'm dividing it by 52 the number of weeks in a year. So here is the cost rent. Then the real transport cost. I multiply it by 2 because he does ride twice a day to go to work and come back to home. So here it will be the average distance it will make every day to work, and I'm dividing it by his speed, 11 kilometers, and I multiply it by 5 the number of days he works on a week, and I multiply by it by the money he could have earned if he was working instead of going to work. So after I use when I have the data, all the cost data, I use the algorithm we talked about before to find which place is better. So now I will show you how does it work. And okay, so now the flat to choose is the 10th district of Paris. In Paris there are 20 districts, and the price per week, including the total cost, so rent cost and transportation cost, will be 243 euros.
Speak a little bit about wine, and we'll answer the question, which is the most cost-efficient wine producing region in France regarding transportation cost? For that, we decided to choose the 5 most important French wine producing regions. That means Nouvelle-Aquitaine, this is Bordeaux, Grand Est, this is Alsace, Bourgogne, Rhône, and Provence-Alpes-Côte d'Azur. So what we want to do is to minimize the transportation cost of a truck. We decided to choose a truck. And we'll do that for each region regarding to 8 cities. This is the biggest city, the bigger city in France, but this is also the capital city of the region, because we'll consider that the transportation cost inside the region then is 0, and it's allowed then to have a higher number of inhabitants, because, for example, for Paris, it will not be only Paris, but the entire region. So we have 11 million inhabitants. And so to cover first all the entire population of France, you can see we have 50 million people. Then we will use also the proportion, because we want to know if the truck will go more in Paris, more in Marseille. So we'll do that. This is another assumption regarding to the number of inhabitants, because we will consider that if there is more inhabitants in Paris, there is more consumption of wine, so we will go more there. And to finish, we'll use some data, and you can see we have the gas price or the gas consumption of a truck, road toll price on average, and driver gross wage, and all is in kilometer because this is kilometer. Now we will implement our launch our program, and the aim of the program is to have at the end the cost here. To minimize after the cost, I let you see in the introduction. You can see we explained that it's always the same. It's after length, all of that is to minimize the cost. So I'll let you see. It's not very difficult, but just with what I want to show you is I calculated my cost. So for that, I have done a loop for G is equal to 2 to 6. Excuse me. This is the region, and for E is equal to 3. You can see 3 to 10, 3, because in VBA, C is 3, A is 1, B is 2, etc. So 3 to 10, I have done this loop. S is equal to 0. So for example, at the beginning, we'll take Aquitaine. S is equal to 0. Then N will take the value of these cells multiplied by these cells. Then S, we will do another loop, and S will be is equal to the result of that plus these cells multiplied by these cells, etc. And at the end, we will have the cost. And with our minimization program, we will have the name of the best region. If I executed this program, you will see we have the cost here who appears, and a message says the region with the lower cost is Bourgogne with a total cost of €326.